In this session, we will look at gauge pressures and other measurements on a normally operating 410A system, as well as an R22 system. We will get a brief overview of some of the calculations that we use in the trade, such as superheat and subcooling. The first system we will look at is a 410A system. It has a low side pressure of 118 psi, a high side pressure of 350 psi. It has a saturation temperature in the evaporator of roughly about 40 degrees Fahrenheit. And it has a saturation temperature in the condenser of roughly about 107 degrees Fahrenheit. This particular system is set up to run about 400 CFM per ton, and it is utilizing a TXV as a metering device. The system also has a suction line temperature that's read at the sensing bulb of the TXV of 50 degrees Fahrenheit. And it has a calculated superheat of 10.3 degrees Fahrenheit, which I will cover here in a minute. This system also has a 95-degree liquid line temperature that is read at the exit of the condenser itself. And then it has a subcooling measurement or calculated measurement of roughly about 12 degrees, and I will cover that in a minute as well. There's two ways to figure out saturation temperature inside the evaporator. First, we take a low side pressure reading on the evaporator, and we will match that pressure up to a PT chart or a pressure temperature chart. As you can tell, at 118 psi, then if we follow to the left on the pressure temperature chart, we'll notice that it's about roughly 40 degrees Fahrenheit. So 40 degrees Fahrenheit equals 118 psi in a 410A system. The second way we can check this is by hooking up our gauges and reading the low side pressure. Once again, at 118 psi on the outer blue ring, you'll see that if there's a dotted line, and if you follow that into the pink ring on the inside, that's 410A temperatures that correspond to the associated pressures on the outer ring. So we notice that 118 psi equals roughly about 38 to 40 degrees Fahrenheit, whether you look on a pressure temperature table or you look on your compound gauge itself. Now let's look at these readings again so that we can tell how to calculate superheat. Superheat is the difference in temperature between the measured suction line temperature at the sensing bulb of the TXV and the evaporator saturation temperature. So in order to calculate superheat in the system, we must subtract the saturation temperature from the suction line temperature reading. So 50 minus 39.7 would give us 10.3 degrees of superheat. Or we have added approximately 10.3 degrees of heat above the point in the evaporator where the refrigerant has changed state from a liquid to a vapor. Superheat is critical to the life of a compressor and the efficiency of the system. We will cover this in detail in another session. There are also two ways to figure out the saturation temperature in the condenser, and they're very similar to the saturation temperature in the evaporator. The only difference is we will start looking at the high side pressures for this. So on the right we have the high side pressure compound gauge, and on the left we have the pressure temperature table. So once again, if we look at the 350 psi and we look at the pressure temperature table, we'll notice that 350 psi is roughly about 107 degrees Fahrenheit. If you look on the right-hand side where the gauge is, roughly about 350 psi pressure on the outer ring of that gauge correlates to the pink inner circle, which is the temperature correlation for 410A. So 350 psi equals roughly about 107, 108 degrees Fahrenheit. So let's look at the readings again so that we can tell how to calculate superheat. Subcooling. Subcooling is the difference in temperature between the measured liquid line temperature at the exit of the condenser, which is 95 degrees on this unit, and the condenser saturation temperature, which is 106.8 degrees Fahrenheit on this unit. The true definition of subcooling is any heat that has been removed from a refrigerant below its saturation point. So in order to calculate subcooling in the system, we must subtract the condenser saturation temperature from the liquid line temperature reading, 106.8 minus 95 degrees would equal roughly about 11.9 degrees of subcooling, or we have removed almost 12 degrees of heat below the point in which the vapor will return into a liquid form. Subcooling is also critical to charging a system with a TXV and for the compression ratio. We will cover this in detail in another session as well. On this screen, we can see that this is an example of an R22 system. As you can tell, the pressures are slightly different than that of a 410A system, but the superheat and subcooling calculations are all done exact same way. So if we take the saturation temperature minus the suction line temperature, we can come up with a superheat reading. And if we take the saturation temperature of the condenser minus the liquid line temperature, then we will have the subcooling reading. And they are just as critical whether it's R22 or 410A. Please feel free to reach out to me with any questions that you may have. My email address, dblackstone@airforce1.com. My cell phone number is 1614-802-9887. Feel free to text me or call me anytime. Or you can message me on Microsoft Teams. Thank you.